Question number 81. For a hypothetical reaction, the reaction is given 2A in the solid state is getting changed into the product B that is in gaseous state and delta H is more than 0. What does it mean? It means this is an endothermic reaction. Partial pressure of B at equilibrium can be increased by. It means you just want to increase the partial pressure of B at equilibrium. What you need to do? Here you can add mole of A. You can decrease the volume of the container as per option 2, then increasing temperature or by adding catalyst. You need to know. First of all, if I talk about the reaction given here, that is 2A in the solid state, it's getting changed into B, that's in gaseous state. If I talk about the equilibrium constant for this reaction, that would be dependent on B only. Why? Because B is in the gaseous state, this is heterogeneous equilibrium, and K equilibrium is equal to the partial pressure of B only. This way. It means if you just want to increase the partial pressure of B, what you need to do? You need to just increase the equilibrium constant. K equilibrium you need to increase. Then we have to just look at the given option. If I talk about addition of moles of A, there would not be any effect on K equilibrium. Why? Because it is in solid state. Further, if you decrease the volume of the container, in that case the partial pressure of B would be decreased because less number of moles would be there. Further, increasing temperature, as this is endothermic reaction, because delta H is positive here, it means as you raise the temperature, then equilibrium will shift in the forward direction as per Le-Chatelier principle, and it means this is the correct option. While if I talk about addition of catalyst, on adding catalyst, rate of forward reaction as well as rate of backward reaction increases. It means you cannot increase the partial pressure of B by addition of catalyst. So only one option is correct, that is option 3. So I'll choose option 3 as my correct answer. After this, there's another question. Question number 82. For the reaction, we have this redox reaction given here. The molar ratio of Cl negative to ClO3 negative in balanced redox reaction is. First of all, I'll just break this reaction into two half reaction. First would be Cl2 is getting changed into Cl negative. Further, the Cl2 is getting changed into ClO3 negative also. The same element is getting oxidized as well as reduced. In the first reaction that I have written here, the Cl2 is getting changed into Cl negative. The Cl2 is getting reduced, while in other reaction the Cl2 is getting oxidized. These two half reactions we have, let's balance them. So I'll just multiply 2 here to balance the atoms of chlorine. Let's balance the charge. 2 negative charge I need to just add here. After that we have Cl2, it's getting changed into ClO3 negative, so I need to just multiply 2 here. After multiplication of this 2 here, now let's balance the oxygen. 6H2 I'll multiply at this side and 12 OH minus at this side. I have balanced all the atoms. You can clearly see 12 oxygen atom at this side and 6 plus 6, 12 oxygen atom at right hand side are also there, and 12 hydrogen atom at this side, 12 hydrogen atoms at this side. Now we are left with the balancing of the charges, 12 negative charges at this side and 2 negative charges at this side. So what we need to do, I just have to add 10 electrons at this side. Now we have two half reactions, 1 and 2, both of them I have balanced. Now let's balance the number of electron in both of these two reactions. So to make them equal, what we need to do, we need to just multiply 5 in the equation 1, and now equation 1 can be rewritten as 10 electron plus 5 Cl2 is giving you 10 Cl negative. This becomes the equation 3, and now just add equation 2 and 3, we will get, these two get cancelled, and now 12 OH minus plus Cl2, so I can write here 6 Cl2 giving you 2 ClO3 negative plus 6H2O plus 10 Cl negative, and this can also be rewritten as 6 OH negative plus 3 Cl2 giving you ClO3 negative plus 3H2O plus 5 Cl negative. This is the balanced chemical equation in the simplest form. Now what we need to find out here, the ratio of Cl negative and ClO3 negative. Where's Cl negative? The Cl negative is here and ClO3 negative is here. So the ratio becomes 5:1. This is the ratio. Where this ratio is given? This is correctly given here in option 4. So just choose option 4 as your correct answer for this particular question. After this, now question number 83. If vapor pressure of the solution of 5 gram non-electrolytic solution in 100 gram of water is 720 mm Hg and the vapor pressure of pure water, it means pure solvent we are talking about, at the same temperature is 740 mm of Hg, then the molar mass of the solute is. We have different options given here. We need to just find out. So first of all, if we just want to find out the molar mass of the solute, we need the colligative property, that is relative lowering of vapor pressure. What's the formula? Just recall. The formula is delta PS. We're talking about the change in vapor pressure while formation of the solution divided by the vapor pressure of the pure solvent. That should be equal to Chi2. That is the mole fraction of the solute. Now just place the values here. So delta PS, final vapor pressure after formation of the solution is 720 mm Hg, and if I talk about the pure water, the vapor pressure was 740 mm of Hg. So what is delta PS here? That is 740 minus 720, you know that, divided by the vapor pressure of this pure solvent, that is 740 mm Hg. After that, mole fraction of the solute. How do we calculate that? We know that mole fraction of the solute is equals to moles of the solute divided by the total number of the moles present in the solution. So here I can write N2 by N1 plus N2. What is N2? Given mass of the solute divided by its molar mass. So given mass of the solute is given in the question, that's check, 5 gram. And we don't know its molar mass because that we need to find out. So 5 divided by, let's assume that molar mass is M, divided by the total number of the moles present in the solution. How do we find it? We know that the weight of the water present there in the solution is 100 gram. So weight of the solvent is 100 divided by its molar mass. What is that? 18 plus 5 by M that we need to take. Just solve this. Here the 740 minus 720 becomes 20 by 740. So I'll write here 20 by 740 and that should be equal to here 5 by M that I'm taking here. In this case 1 by, this is 100 by 18 and this is 5 by M. So it can be written as 18M and then it can be written as 100M plus 18 into 5, that's 90. And what will be written here? It's already written. This M can be cut in this way. It can be cut 1 by 37 it would be. Now can be simplified by writing 1 by 37 is equal to 5 into 18, that is 90 upon 100M plus 90. Now just solve this for the value of M. This would be written as 37 into 90 here, that is equal to 100M plus 90. Now it's your turn. Just solve for the value of M and you'll find that M value is equal to 32.4 gram. This would be your final answer. Where this answer is given? It's correctly given here in option 2. So the correct answer for this question becomes option 2. After this, question number 84. Which of the following reactions will not produce diborane? What is diborane? You know that, B2H6. And if I talk about these reactions, BF3 is combining with lithium aluminum hydride, NaBH4 combining with iodine, BF3 combining with NaH, sodium hydride, further boric acid combining with water. We need to know that in which case diborane is not produced. I'm just going to tell you. In case of the reaction of boric acid with water. I'll just write the complete reaction. That is BOH. Negative, this ion would be formed, along with that H3O positive ion. It means in this case there is not the formation of diborane. While if I talk about the other reaction, just have a look on that. We have these reactions. BF3 is reacting with lithium aluminum hydride to give you diborane, lithium fluoride and aluminum fluoride. Similarly, sodium borohydride is reacting with iodine to give you diborane here. And here also BF3 is reacting with NaH, sodium hydride, 450 Kelvin temperature to give you B2H6. It means in this case also we are obtaining diborane. It means only one case is left. What's that? That is given here in option 4. That's why I'll choose option 4 as my correct answer. After this, question number 85. Number of Faraday required to deposit 10.4 gram of chromium from Cr2SO4 whole thrice is. Atomic mass of chromium is also given, that is 52 U. Let's check. We have the process in which Cr2SO4 whole thrice is getting changed into Cr. It is getting to deposit in the form of chromium. It means in this case there is a change in oxidation number. With the help of that we can find out the N factor, and that will give us the number of Faraday required per mole. So this can be represented here, that in this case Cr3 plus is getting changed into Cr. Oxidation number of Cr is 0 here. So in this case, what would be the number of Faraday? 3 Faraday of electrons are required in this case. Now, first of all, let's find out the number of moles of Cr2SO4 whole thrice available there. So in this case, moles of the given salt is equal to 10.4, the given mass, divided by its molar mass, 52. These are the mole. And now the number of Faradays required. Those would be equal to the moles which are given multiplied by the Faraday required for the 1 mole. 3 Faraday we are requiring here. So on solving you will find out that the total number of the Faraday are 3 by 5. If you solve this you will find it out. And if these are the number of Faraday required, we can easily choose option 2 as my correct answer. I hope this question is also clear to you. Let's take next question.